Welcome to Chapter 1, Relations and Functions, one of the most important and scoring chapters in Class 12 mathematics. In this chapter, we will build the foundation for many advanced topics you'll study later, including calculus. Think of relations as connections between elements, and functions as a special type of relation with a clear rule. Don't worry if this sounds abstract right now. We will break everything down step by step with simple explanations and clear examples. By the end of this chapter, you'll not only understand the concepts, but also feel confident solving board exam questions. In this chapter, our goal is not just to learn definitions, but to truly master the concepts. We will understand what relations are, how to represent them, and how functions are formed from them. Visual proofs and diagrams will help you see patterns clearly, instead of memorizing blindly. We will also connect concepts logically, so each idea builds on the previous one. Finally, we'll focus on exam strategies, how to identify question types, avoid common mistakes, and solve efficiently. This structured approach will make the chapter easier, more interesting, and highly scoring in your board exams. Let's quickly understand the roadmap of this chapter. First, we study types of relations, like reflexive, symmetric, and transitive, which help us understand how elements are connected. Then we move to types of functions, where we learn about one-one, onto, and other classifications. Finally, we study composition of functions and inverse functions, which are extremely important for higher mathematics. If you understand these three parts clearly, the entire chapter becomes simple. Think of this as your blueprint. Follow it step by step, and you'll never feel lost while studying this chapter. Now let's look at two extreme types of relations, empty and universal relations. In an empty relation, no element is related to any other element. It's like having a group where no one interacts with anyone. On the other hand, in a universal relation, every element is related to every other element. It's the complete opposite. Everyone is connected to everyone. These are important because they help us understand the boundaries of relations. In exams, questions may test your understanding of these extremes, so always remember, empty means no pairs, universal means all possible pairs. These three properties, reflexive, symmetric, and transitive, are the backbone of relations. A relation is reflexive if every element is related to itself. It is symmetric if whenever A is related to B, B is also related to A. And it is transitive if A related to B and B related to C implies A is related to C. Think of these as logical rules that define how relations behave. These concepts are very important because they are frequently asked in board exams. Once you understand these clearly, many questions become straightforward and easy to solve. When a relation is reflexive, symmetric, and transitive all at once, we call it an equivalence relation. This is a very important concept. It helps us group elements into what we call equivalence classes. Think of it like grouping similar items together based on a rule. Each group contains elements that are related to each other. Also, no element belongs to two different groups, and all groups together form the entire set. This idea is widely used in mathematics. In exams, focus on checking the three properties carefully. That's the key to identifying equivalence relations. Let's apply what we've learned and actually prove an equivalence relation. The given relation is A is related to B if, quote, A minus B is divisible by 2. First, reflexive. Any number minus itself is 0, which is divisible by 2, so it is reflexive. Second, symmetric. If A minus B is divisible by 2, then B minus A is also divisible by 2, so symmetry holds. Third, transitive. If A minus B and B minus C are divisible by 2, then their sum, A minus C, is also divisible by 2. Since all three properties are satisfied, this relation is an equivalence relation. Now let's understand three important types of functions: injective, surjective, and bijective. An injective function means every input has a unique output. No two inputs share the same image. A surjective function means every element in the codomain has at least one pre-image, so the entire codomain is covered. A bijective function is the best of both. It is both one-one and onto. This means every input maps uniquely, and every output is covered. These concepts are extremely important, especially when we study inverse functions, so make sure you clearly understand the differences. Here's an interesting concept. Does one-one always mean onto? The answer depends on whether the set is finite or infinite. For finite sets, if a function is 1-1, it will always be onto. Why? Because the number of elements in domain and codomain is fixed. But for infinite sets, this is not true. For example, if we map natural numbers to their doubles, every input is unique, so it is 1, 1. But not every number is covered, so it is not onto. This distinction is very important and often tested in exams, so remember this key difference. This slide shows how the domain can completely change the nature of a function. Take the function f of x equals 2x. If the domain is natural numbers, the function is 1, 1, but not onto, because values like 1 cannot be obtained. But if the domain is real numbers, the function becomes both 1, 1 and onto. This means the same function behaves differently depending on the domain. So always check the domain carefully before deciding whether a function is injective or surjective. This is a very common mistake students make in exams. Think of composition of functions like an assembly line. One function works first, and its output becomes the input for the next function. For example, we first apply function f to x, and then apply function g to the result. This is written as g of f of x, or g-ring operator f. The order is very important here. Changing the order gives a completely different result. Composition helps us build complex functions from simpler ones. It's a powerful concept and will be very useful when solving higher-level problems, so focus on understanding the flow clearly. Not every function has an inverse. For a function to be invertible, it must be bijective, that is, both 1, 1 and onto. Why? Because each output must come from exactly one input, so we can reverse the process uniquely. If multiple inputs give the same output, the inverse cannot decide which one to pick. Mathematically, a function is invertible if composing it with its inverse gives back the original input. So remember this golden rule. Only bijective functions have inverses. This concept is very important and directly linked to many exam questions. Let's now apply the concept and find the inverse of a function. We are given f of x equals 4x plus 3. First, replace f of x with y. Then, swap x and y to begin finding the inverse. Next, solve for y by isolating it step by step. This gives us the inverse function, gy equals y3 divided by 4. Finally, we verify by composing f and g. If both f of g of x and g of f of x give back x, the inverse is correct. As we see here, the result is verified. This step-by-step approach is very important for exams. Follow it carefully every time. Let's quickly revise the entire chapter in one powerful summary. First, relations are defined using 3 key properties: reflexive, symmetric, and transitive. When all 3 are satisfied, we get equivalence relations, which form equivalence classes. Next, we studied functions: injective, surjective, and bijective, each with its own importance. Then we explored operations like composition, where functions combine, and inverse functions, which reverse the mapping. The key takeaway is that all these concepts are connected. If you understand the flow from relations to functions to operations, the entire chapter becomes logical, simple, and easy to score in exams. Before we end, here are 5 powerful exam hacks. First, to disprove a relation, just give one counterexample. Second, use variables like a, b, and c to prove general results. Third, always check and state whether a function is bijective before finding its inverse. Fourth, never ignore the domain. It can completely change your answer. And finally, structure your proofs clearly using headings like reflexive, symmetric, and transitive. With this, you are fully ready to tackle relations and functions confidently. Keep practicing, stay consistent, and you will score well. Thank you for watching, and see you in the next part.